Hello everyone, good afternoon. I'll just wait a few moments for people to join the call and then we can get started with today's session. Great, I can see the numbers creeping up. I think people are starting to join us. Great, okay, I'll make a start and people can join us as we move through. So good afternoon everyone and welcome to this webinar from Cambridge Centre for Evaluation and Monitoring, which is all about improving student success in maths and what impact baseline assessments can have. So before we start the session and I hand over to today's presenter, Karen Barker, I would just like to go through a little bit of housekeeping for the webinar. So to ensure good sound quality, all members of the audience are muted. If you'd like to ask a question, please do ask questions throughout the session. You can post them in the questions section. It should be located on the right-hand side of your screen. It's a little box with a question mark in. So please do type your questions in throughout the session as they come to you or any thoughts you might have. And at the end of the session, we'll go through as many questions as we can. So you'll receive a certificate of attendance sent to your email inbox an hour after the webinar finishes, and you'll receive a copy of the webinar recording sent within the next few days. Before we get onto the main content of today's session, I just wanted to say a few words to introduce Cambridge Chem. So, lovely, thanks Karen. So Cambridge Chem is the Centre for Evaluation and Monitoring, and we've been working with schools for 40 years in over 110 countries. We're known for our evidence-based research approach to baseline informative assessments, and we use extensive data sets to support future outcomes and development. We work with schools, ministries, and associations to transform the outcomes of the students they teach. In 2019, we became part of the University of Cambridge, which has supported our reach and abilities to support young people across the world. We help teachers turn data into knowledge, we bridge the gap between research and practice, and we provide evidence to support good decision making. So that's enough from me. I'll hand you over to Karen Barker, who will be taking you through today's session. So I'll come off camera for now, but I'll join you again at the end for the questions section. Over to you, Karen.
Well, good afternoon, everybody, and welcome to my presentation on how to put YELLIS assessment data into practice in mathematics. Just a little bit about me. I'm a deputy head at Finborough School in Suffolk, and I'm a qualified assessor. So my large part of my role is assessment, and I've been working lately with Chem in terms of using the data and interpreting MIDIAS and YELLIS and ALICE data, and also applying it to specific subjects. So what is YELLIS? It's for 14 to 16-year-olds, those in year 9 to 11, and it gives valuable insights into students' cognitive strengths and weaknesses. Now, if you're not entirely familiar with YELLIS, the tests are adaptive. So the questions are altered according to the students' success or otherwise. So if they're being successful in answering the questions correctly, then the questions become more difficult. And if they are less successful, then the questions become more straightforward. Well, hopefully anyway, the students might not agree. Now, the whole point of today's webinar is to make the point that these tests should not be used in isolation from other information about students. And using the information we glean from YELLIS as well as other information we have about students, we can then use the information to adapt our teaching strategies, resources, and even pace in lessons to meet the needs of individual students. And then, of course, to enhance their learning outcomes. Now, the tests themselves provide standardised scores, and you will receive or be able to download one of these profiles for each of your students. The tests have a mean of 100, which is absolute average, with a standard deviation of 15. So the average range is from 85 to 115, with above average 116 to 129, well above average 130 plus. And then the other way, 70 to 84 is below average, and less than 70 is well below average. Now, the individual student profiles, of which this on the right is one, you'll see the little markers extending beyond the data points, and they show a 95% confidence limit for each score. And so you really have a good graphic identifying the strengths and weaknesses in performance across the 3 subtests. So when the confidence limits do not overlap, this means there's a discrepancy between the scores. You know, they're significantly different. And so understanding these provides some likely reasons why students are working below expectations. Now, what I want to do first of all is just go through each of the subtests and explain what they're measuring, and some of aspects that perhaps they're not measuring, and how it's important that we understand these. So firstly, I'm going to talk about the verbal reasoning. And even in maths, you know, strong spoken and written verbal reasoning skills are essential for success. And of course, maths is a language all of its own. So, you know, learning that vocabulary, as well as analysing and evaluating information and so on, it's extremely important that students have good verbal reasoning skills. Now, verbal reasoning is made up of receptive language, so the words we understand, as well as expressive language, so the way in which we use that receptive language in spoken language and written communications. Now, Chem vocabulary measures receptive language and the speed students recall the meaning of words. So it's looking at their fluency in how they can retrieve the language they understand from their lexicon and to be able to apply it to a number of words that they see on the screen. They have to match, find the closest matching word. But it's also important to be aware of students' strengths and weaknesses in their broader language skills. So, for example, a student might have high vocabulary score, but poor expressive language skills. So they're not expressing themselves at a level that the test score suggests. And it's important, you know, you realise this. Next, mathematics. Now, these are timed assessments, and so they're really showing the speed a student can work rather than overall mathematical ability per se. So students, you might find, can do the calculations, but they might not be able to do it within the time allowed. So then their scores might not be as high as you would anticipate. And this, therefore, might provide you with some evidence that they need extra time. Now, the overall score that you'll be provided with the Yellis tests is actually a combination of vocabulary and mathematics scores. It doesn't include the patterns or the non-verbal reasoning score. And then the potential grades which you receive are generated by a regression analysis from a large pool of results data. So your students' potential grades are based on the results that students in the data pool achieved with similar profiles. Now let's go on to non-verbal reasoning. That's patterns. Now, NVR or visual skills are very important in all learning. They're linked, related to the ability to match patterns and reflections, rotations. So it's really sort of visual intuition, how they're using that visual information. Now, these skills are important for all of these aspects of learning. In addition to that, they're also important for language skills. So reading comprehension has an element of non-verbal reasoning in it. And then, of course, the other language skills. All of these aspects of grammar and so on, they require analytic thinking, which is rule-based, which is really non-verbal reasoning. Now, mathematics and NVR, they're closely related. And students might be significantly more able in one than the other. And they might show up probable difficulties in mathematics if they've got a high math score but a low reasoning score, the other way round. And you might be wondering why on earth they're not able to solve problems when their math score is so high. So let's look at that in a bit more detail. So here indeed is a student with a relatively high mathematics score and a significantly lower non-verbal reasoning score. You can see that the confidence limits don't overlap. And again, their vocabulary as well is much, much higher than both their maths and their non-verbal reasoning. And because their overall score is 109, you might be wondering why on earth they're not achieving their potential. And it could be linked to this much, much lower pattern score. So now this student might be able to solve calculations, but they've had difficulty making justified decisions when using data. They can't select the right data. They struggle to analyze and evaluate, and so on. They might really struggle with physics, for example, because it's applied maths. On the other hand, you could have a student who has high non-verbal reasoning versus a significantly lower math score. And you think significantly lower, but their math score is still within average. But relative to their non-verbal score, it's significantly different. So they might be adept at defining and solving problems, but because of their relative numeracy difficulties, they might need support to remember equations, especially when you look at their vocabulary score. So this could potentially be a dyslexic student. So their vocabulary is lower than their maths or their non-verbal reasoning, so they're going to need support to remember equations, especially if their working memory might be weaker. So it's having all these extra bits of information about the student to help you to understand their wider difficulties. And in the light of this, we are just going to consider briefly executive functions. Now, I've already suggested that verbal and non-verbal skills are interdependent. We can sometimes think of them as separate entities, but they're not. They actually overlap quite significantly. They are difficult to separate. Executive functions they're considered in many ways non-verbal skills, and yet they enable us to successfully understand language, to communicate and interact socially. Now, although these are not measured by chem tests, knowledge of a student's executive functions can be important in explaining underachievement. So here's some executive functions that you might immediately recognize in some of your students that have difficulties, perhaps those with ADHD, have difficulties with impulse control, or they might have difficulties organizing themselves. An autistic student might have difficulties with flexible thinking, dyslexic students with working memory difficulties, and so on. So having an appreciation of your students' executive function skills is important as you consider their YELLIS scores. So we'll just go on and look at some of the adaptations you can make as you consider students' weaknesses. So, for example, as we consider weak language skills in maths, because that's important consideration, because are they having difficulty learning vocabulary and understanding the vocabulary? So some strategies here to help you. I'm sure you use a lot of them anyway, but just a few more ideas. For some students, colour coding, key vocabulary and signs is very important. Help them to consistently, say, if they struggle recognising an addition and a multiplication sign, get them to highlight them in different colours, for example. Although make sure they're not getting muddled and they're highlighting the wrong sign with the wrong colour. But that can be helpful. And even in exams, train them up to actually highlight the signs when in the question on the paper, so that they can be really sure they're performing the right operation. And I'm sure you'll do this anyway, but regularly review learning to make sure those connections are being maintained and even strengthened. Doing a lot more peer-to-peer working. It can actually be motivational for a student to be paired with perhaps a less able student, or somebody who would not normally be considered able, suddenly think, oh, they're able to do this aspect of maths. So careful pairing can also help with improving performance. Now, for maths specifically, I think quite often students can really struggle to understand what is the point. Why am I doing this? Why am I bothering to learn this topic? What good is it for me? So it's really important to try and make those connections. Using real life examples to promote a deeper grasp of the relative relevance of mathematical concepts, and providing explicit step-by-step instruction sheets, especially for those who have weak memories. They just will forget from one lesson to the next how to go about solving a particular calculation. So they might need those step-by-step instructions, whether it's posted on the wall or a little sheet in their books or whatever it might be, to just help their memories. Again, using colour. Colour really does help some students. Others, it has no effect. But for some students, it really does help. So we've already mentioned signs, but also tricky parts of equations. If you don't use colour, start to try it out Ask your students if colour would help, and you might be surprised by their responses. Mentioned this as well just now, but now students as teachers, perhaps get them up to the front, demonstrating how they solved a certain calculation, and addressing misconceptions through really precise, directed Q&As. And this is very useful, or these are very useful as starters, using flashcards to practice recalling information. All those, perhaps the first few questions on the foundation papers, where they have to know their basic multiples and so on. Just to have a little flashcard, so that's at the beginning of lessons for your starter, just to practice all those more straightforward questions at the beginning of each lesson. Now with weak NVR, you really have to make the abstract as explicit, tangible and concrete as possible, because they just don't see the abstract. So don't assume that they will know. It really is a case of trying to make things as concrete as possible. Now, a little bit of research here from Sadowski with his dual coding theory. So teaching vocabulary, if you combine words with definitions and even pictures, this can help some students. It won't help all, but for some students it really does help build up those visual verbal pathways for their processing. So, really making the words concrete with visual images. So that might be something you'd like to consider. And some students it might help them if you use gestures, demonstrating practical tasks. I was doing some access arrangements assessments this morning, and one student was particularly adept at the manual imitation assessment I was doing, and I asked her if she really benefited from a demonstration of a task, and she was very enthusiastic about the fact that yes, she did. So sometimes if you actually model what you'd like them to do, how you'd like them to go about it, even modeling the answer and so on, just demonstrating the practical nature of the task. And of course, use real life examples, and this will make maths more relevant as well. Get them to question why things are done the way they are. They really need to start to think about intellectual curiosity to try and improve their problem solving skills. And this is where your dyslexics are quite good with the out of the box thinking. But encourage more students to perhaps think in different ways. And for those with weak executive function skills, provide crib sheets to solve calculations, those lovely little triangles to remember equations. Provide, again, explicit checklists, timers. Go through that, step by step to answer calculations. Really raise their awareness and check for common errors. Even encourage them having personalized checklists. So because there will be some students who find certain operations difficult and others will have less difficulty. So if they do struggle to remember to do something in a certain order, get them to have a little checklist to tick it off. Even a dry wipe laminated sheet they can just wipe off and use next time. display instructions for tasks. And also for your students who struggle with attention and focus, really, focus on using their name, so to get their attention. I wanted just to have a quick look at some a profile of a student with ADHD, for example, talking about using a name to grab someone's attention. Now, Jasmine, she's got ADHD. Her relatively high vocabulary is compromised by a significantly weaker NVR. So for Jasmine, her verbal written language poorly structured and confused. And so to be able to support her, I would suggest helping her with specifics. So again, being explicit in terms of how to go about planning and organising her written work. If she's having to show her workings, be really explicit how she needs to go about this. Explicitly explain how to interpret diagrammatic information, because she just won't see it. Help her with problem solving and decision making. As I've said earlier, make it as concrete as possible. She might need explicit guided reading assistance through those long wordy questions. Use concrete apparatus. So often when they're in senior school, high school, they think it's a bit babyish. But if it's a normal way of it's accepted as a normal way of working in the maths class, hopefully they'll all benefit from having concrete apparatus available to them, or maths games. She needs extra time. So a lack of focus, weak NVR, means she takes longer than expected to process information, especially when reading. And she'll also benefit from rest breaks to refocus. So what I've gone on to now, just emphasising the use of mark schemes and examiners' reports with students. And this is really important, I feel, just to really point out to them how they can use the mark scheme to show them how the marks are awarded, and then also what the examiners have had to say about the way in which students have answered the questions. So I've just gone through, just picked out a few issues from examiners' reports, and just given you some strategies as to how you might actually go about improving your students' work or their use of calculators and so on, the issues that the examiners have pointed out. The middle column there, I've tried to give some sort of explanation as to why they might be presenting their work in a disorganized way, or they didn't use a calculator or whatever. So I haven't tended to repeat the likes of dyscalculia, but it could be a factor in obviously in all of these issues. But things like work presented in a disorganized way, it really is a case of explicitly teaching ways to present work. You will have students who perhaps have developmental coordination disorder who really struggle with spatial awareness. So actually being able to present their work in a logical step-by-step way that looks neat might be a challenge to them, but persevere and give lots of encouragement. Didn't show they're working. If you have a student who is ADHD, perhaps even dyslexia, they somehow got a holistic approach. They get the correct answer, but they don't know how they got there. And then trying to unpick how they got there then actually slows them down. So again, explicit teaching of how to show your working might help them as well. But what's going to be important for them is how marks are allocated. So that's really important to work with them on that, so that they can really appreciate how those marks are going to be allocated. Make sure they know how to use their calculator and that there's some available to be in the exams if they didn't bring their own. Those who use inefficient non-calculator methods, their math skills are so weak, I feel that actually they don't know which formula to use. They just don't know how to get past inefficient methods. But it is definitely worth practicing using that formula sheet and get them to find the hidden formulas on that sheet. Weak language skills, they can really struggle to explain their responses. But again, lots of practice explicitly modelling how they answer the questions. Misinterpreting questions. Perhaps some of them might need support for reading. So actually look for your evidence, give your evidence to your SENCO to see if they can have any assistance with reading in exams. That can be really valuable. Just a few more here. Couldn't identify place values. So again, I've got lots of examples of some concrete apparatus. And then again, more support with reading, encouraging checking. Basic numerical errors, again, you might like to try using colour. So get those highlighters out to highlight the signs. Yeah, it's very difficult when they actually misread their own figures. So try and encourage careful handwriting. And again, they might need extra time to be able to slow down and form their numerals correctly. So that could provide you with further evidence as well, because if you can see that if they actually slow down, the SENCO might indeed be able to provide some evidence or test score for extra time in terms of speed of writing. Because I'm sure if they struggle to write their numerals legibly, they're going to be struggling to produce handwriting legibly, so there might be evidence for extra time there. Yeah, encourage them to have a go if they don't give any response, but sometimes they just don't know what to do, where to start. Again, lots where there's no checking using reverse operations, they need lots and lots of practice. And these memory difficulties. So it's explicit teaching. Don't assume they know. Model using a ruler even. It's amazing the students who don't know how to use a ruler properly, even in year 10, 11. I'm horrified sometimes. Protractor, well, yeah, sometimes they're not, they're quite difficult to get to grips with at times, but not knowing how to use a ruler. So yeah, don't assume they know. And more weak maths difficulties here. I've given some suggestions on highlighting again in colour. Limited knowledge of area, concrete where possible, just practice, practice, practice. With the providing support to answer those longer questions requiring problem-solving skills, again, be explicit, working through step by step. Use drawing, sketching. but weaker students will just really have difficulties overcoming these difficulties because they just genuinely don't know where to start. And again, with the trial and error, they don't know. I just thought trial and error. They don't know where to start. They genuinely don't know. So very briefly, I'm conscious time is running away with us. So just looking at a couple of exam questions. Sorry, they're a little bit faint, I think, perhaps. But so with something like this, fairly straightforward question, but again, it's going to throw many of them who struggle with maths. But for range, practice with a list of numbers, taking the lowest from the highest and so on. Rote learn prime numbers, have them up on your wall. They need lots of practice with equivalence in this sort of question. But there's lots of real life applications here. And these sorts of questions are good for starter questions. For this one, I would suggest draw the rectangle, label with measurements, look for clues within the question. Square meters equals the area. But some students, they really do struggle with things like what do you do with 0.2 of a sheep. So again, be explicit. What do they do with that question when they've got 0.2 of a sheep? Again, lots of practice working through rearranging equations, explicitly model what to write. And this question posed difficulties as well, according to the examiners, but lots of practice, doubling and halving. Confusion with quantities. And then Darcy making his 100 cookies and work out how much money Darcy received. So he had 16 packets, and what about the odd 4 cookies? And you probably have students saying that he ate them or something. But yeah, so again, being explicit, explaining to them what they have to, if they have to say or do anything, you know, what they have to do with the odd 4 cookies. Practice converting between units. If they're using column subtraction, lots of practice with the layout. Inverse operations, really tricky for some students, but again, practice. The examiners said that students were coming out with turkeys weighing 3,000 kilos, and again, it's really challenging them to actually, you know, think, well, is that reasonable? But for some students, they won't know what 3,000 cubits feels like. They really won't know. So, I mean, I know it's going to be unrealistic for us to provide them with something of 3,000 kilos, but even a kilo, you know, the old-fashioned weights, they need to be perhaps hold. What is a kilo? How much does a kilo weigh? What does it feel like to hold it in your hand? Get a packet of sugar or something, just to help them to understand the reasonableness of answers, because they just won't know. And of course, a lot of children perhaps just don't bake with mum or whatever anymore, or grandma. So it really is a case of making it as concrete and real as possible for them. And then finally, I did wonder about this actually being a practical activity for some students, just trying to break it down, you know, with an LSA. And again, you might just have to just explicitly explain things really carefully. And there we are. Well, I hope you found that useful today. I'm sure there's going to be some
Great,
questions.
thank you, Karen. Just getting my camera back on. There we go. Oh, well, thank you so much, Karen, for your presentation. It was really interesting and hopefully some great ideas there for people to take away with them. So we do have some time for questions. So if you do have any questions, please do use the question box on the right-hand side of your screen to submit them. We'd love to hear your thoughts on any of this, or if there's anything you would like explaining further, we're more than happy to go through that. So just while people are hopefully submitting their questions, I just wanted to talk you through quickly a promotion we have on at the moment for Yellis. So we have joined up with our partners at OCR, and together with OCR, we're supporting schools who might have an absence of SATS data by offering Yellis at only 25% of the cost for OCR math centres. So this is available for existing OCR math centres, but also new centres. So if you or your school is considering using OCR for GCSE maths, if you do become a OCR math centre, you will be eligible for this discount on the Yellis offer. So you'll pay just a quarter of the usual price. So if you'd like to find out more about this offer, and actually I'll put some information in the chat, you can email us. I've got my colleague Suzanne's contact details on the next slide, and have a look on our website as well. So
Okay.
let me just have a look if we've got any questions coming through. So this person is asking, would you recommend using Yellis once in year 9, once again in year 10, and once again in year 11, or would it be something that you'd recommend using more frequently within the year?
To be honest, we only use it, we tend to use it in year 9 now, because we start our GCSEs in year 9. But year 9 or year 10, I think for the vast majority of students, you would only need to use it once. Yeah, I mean, you might want to redo it with a student if you think they didn't actually perform at their best. I think sometimes it's also really explaining to the students the importance of the assessments and to try their best. It's not pass or fail, but it will then help you as their teacher to support them. I hope that helps.
Yeah, definitely. No, that's quite right. So I'll have a look. Yeah, we've got another question, which is around, do you have any advice on building teacher confidence in using this data, and perhaps kind of getting teachers on board with using baseline assessments and using some of the strategies that you've mentioned today?
Yeah, I think it's really a case of providing training and getting to grips with the data yourself, really, and recognizing the patterns in it, and even within the classroom. For example, if students are flagged up by my teachers, I will go and look at the Chem data, but also wider assessment data. I mean, we're very fortunate in the sense that I'm available at school. Much of my day is taken up with assessments, especially now at this time of year with the access arrangements. But I am a qualified assessor, so I do a lot of assessments. If teachers flag students up, you might not have that luxury, shall we say. But it really is a case of looking at the wider student profile and then actually you become fascinated. The more you look at the chem data and then link it to the students' wider challenges, shall we say, or strengths and weaknesses, you'll suddenly appreciate, and hopefully your colleagues will appreciate, the value in it. So if they're looking at a child, for example, who has high receptive vocabulary, but they're autistic, so they've got a very literal interpretation of language. So therefore, they can see the reasons why they're not achieving the potential or predicted grades, because of course they're not able to interpret language at the level that their receptive vocabulary from the chem actually suggests. As I mentioned earlier, with time, the maths score, they might be baffled by their maths score being a lot lower than they'd expect, because this student is quite good at maths. But actually, when they think about it, they take longer to process information. So therefore, the chem test is timed. So suddenly, you can understand that um, the reason for them not achieving so highly on the chem was the fact that they ran out of time to answer the questions. So I think it's seeing beyond the data, and the more your colleagues get interested in it and fascinated by it, in the busyness of school life, I appreciate that. But it really is looking beyond the data and trying to encourage them to look at the students more holistically and broadly.
Yeah, I think that's a really important point, to get that sort of wider view and the more of the context around the student. It, as you say, will probably reveal some things that you might not have thought of before. So we've got one more question. This person is asking about, okay, so how would you use the data in a sort of cohort or class context? So beyond just the individual student, could you apply this more broadly and look at some of the trends in the data per class or per cohort?
Absolutely. Yes, because then you can actually be looking at your class, your set, for example, and then looking at strengths and weaknesses within your set, even within the data. You know, if you just look at the data itself. But then as you look, you can use it then to even begin to group students and think, well, they've got high non-verbal reasoning, but lower math scores. So then you can use that in terms of pairing students as well for strengths and weaknesses.
Yeah, that's a good point. I think that is just about it for questions. Oh, we just have someone asking here, can Yellis be used with IGCSE? And I know the answer to that one. That's yes, it can. So both GCSE and IGCSE. And I think, yeah, we managed to get through all the questions. So just to say thank you so much, Karen, for your time today and for your presentation. Like I say, hopefully some really useful ideas that people can take away with them. If you do have any other questions, or something pops into your head, or you'd like to find out more about what we've talked about today, you can get in touch with us or check our website. So www.chem.org, or I've put my colleague Suzanne's email address on the screen there. She's our sort of a Yellis expert, so between her and Karen, I'm sure they'll have the answer for you. And thank you so much, everyone, for joining us today. We hope you've enjoyed the session, and we hope to see you again at another webinar very soon. Thanks, everyone. Goodbye.
Goodbye. Bye. Thank you.